All right, today's lesson we're going to talk about the distributive property. Just a reminder that if you need to pause the video to make sure you're getting all the notes, feel free to do that. Also, if you need to, rewind to make sure you understand something, please do that. If there's something you still don't understand after the video, please ask me and I'll help you out. So to start with here, we have this large rectangle that's made up of two smaller rectangles. And the question is, how can you find the area of that largest rectangle? Well, one thing you could do is find the areas of the smaller rectangles and add those areas together to get the area of the largest rectangle. That's one way you could do it. So I filled in the dimensions of the rectangle here, or the rectangles, I'm sorry, so we can see what we're working with. So now at the bottom there, what is the area of the largest rectangle? And explain your method. So there's actually two ways we could look at this. One way is I could add the 5 and 7 together. Okay, that's where the 12 comes from on top. 5 plus 7 is 12. So one way would be to take the 3 times the 5 plus 7. Okay, because 5 plus 7 makes up the base, the 3 makes up the height. And if you remember from before, area of a rectangle is base times height. So that's one way we could think about it. Another way, which would give us the same answer in the end here, is I could just look at the smaller rectangle, which is a 3 by 5. So I could multiply 3 times 5 to get the area of that smaller one, and then I could add that to the kind of this medium-sized rectangle here, which is 3 by 7, and get the area of that one. And then if I add those two areas together, I will end up with the area of the largest rectangle. So let's see how these work out. On the left side here, 5 plus 7 is 12, and then I end up doing 3 times 12, which is 36. So I would get 36. Remember, areas and square units on that side. Okay, on the right side here, I would have to do 3 times 5 and get 15. And then I would do 3 times 7 and get 21. And then I would need to add those together. 15 plus 21 is 36. So again, I still get the 36 square units for the area of the rectangle. Okay, now to explain your method, I'm just going to explain what I did on the left side here, because what I did on the right side is really what we explained on the top question there. So on the left side, what we did is we added 5 plus 7 to get 12, and we multiplied that by 3. Okay, and again, the right side is basically what we explained in the top question. So what we used on that first slide was the distributive property. So now what we have here is they're just showing the distributive property in a formula, and they're just using areas of rectangles to model it. So what they're doing is breaking it down as, we're splitting up the one big piece into the two smaller pieces. So how are the two sides of the equation different, and how are they the same? Well, on the left side, what you're doing is you're taking A and you're multiplying it by the sum of B and C. So what you're doing there is you're going to add B and C together first, and then multiply that by A. On the right side, you're taking the product of AB and adding it to the product of AC. So on that side, what you're doing is you're going to take A times B, and then you're going to take A times C, and then what you're going to do is add those together last. So they're the same, or how they are the same is that both sides use multiplication and addition. And that's what the distributive property does, is it uses multiplication and addition. Our other properties have just used just addition or just multiplication. And that's what makes the distributive property different from those other properties we've talked about. All right, so here's how the distributive property works. It tells you to distribute the multiplication to each term inside the parentheses. So if I'm looking at the formula here with the A, B, and C, I'm distributing the A to the B to get AB, and I'm distributing the A to the C to get the AC. So now we're going to throw some numbers in there and see how this works out. So I'm taking the 3 and I'm going to distribute it to the 5. So that's going to give me 3 times 5. And then I'm going to take the 3 and distribute it to the 7, and that's going to give me 3 times 7. So on the left side, what I would have, 5 plus 7 in the parentheses is 12, and I have the 3 here. On the right side, I'd have to do both sets of parentheses first, so 3 times 5 is the 15, and 3 times 7 is 21. And again, you can see how it works out. 3 times 12 is 36. 15 plus 21 is also 36. Okay, so again, we actually used the distributive property in that first example that we did in the lesson here today. The next couple slides here again are just some notes that you can reference and take a look at as you have time. If you'd like to pause the video and do that now, you could. But it is stuff that we've already talked about here in the video. So do that as you need to. Again, just looking at this example again. And again, here's the example, modeling it with the rectangles, modeling the distributive property with the areas of the rectangles. All right, so in this example here, we're looking at this rectangle on the right. The height of it is 3 units. For part B, we're just identifying the length of the bases of each of the smaller rectangles. So one is 2 units and one is 5 units. For part C, it wants us to use the distributive property to calculate the area in 2 different ways. So the first part, calculate the area of each smaller rectangle, then add those areas together. So what we would be doing on that side is taking the 3 times 2 and adding it to the 3 times 5. So the 3 times 2 would give us the area of the smallest one. 3 times 5 would give us the area of this medium-sized one. So 3 times 2 is 6, 3 times 5 is 15. And of course, if we do 6 plus 15, we'll get 21. And because it's area, that would be square units. Okay, the other one asks you to do it to just calculate the area of the large rectangle using 2 plus 5 as the base. So then what we would have to do there is take 3 times 2 plus 5 like that. That would give us 3 times 7. And 3 times 7 also equals 21 square units in this case. All right, our next example here, we are just proving that the distributive property works for this. So again, if you distribute that 8 times 5, and you distribute the 8 to the 10, that's where your 8 times 10 comes from. So if I work on the left side here, I'm going to have 8. 5 plus 10 is 15. Over on the right side, 8 times 5 is 40. 8 times 10 is 80. On the left side, if I were to take 8 times 15, I would get 120. And if I take 40 plus 80 on the right side, I also get 120. Okay, so that works. On this slide, we're looking at some more examples of the distributive property. The only difference here is they're using the formula and having you substitute the numbers for A, B, and C into the formula. So take a moment and get these examples down. Again, think about them as you're writing down. Think about what's happening. So take a second here, pause the video, and make sure you get these down and that you understand them. Again, if you have a question, please raise your hand and ask me, and I'll come help you out. Okay, on this problem it says, do you think that you can distribute multiplication using subtraction? Say why or why not using numbers or area models. So what we have is this rectangle here, and what we want to do is we want to find the area of just the shaded part, and we want to subtract out this white rectangle. So what I'm going to do here is I'm going to have the 3 times, and the whole largest rectangle is 5, but I want to subtract out that 2. So I want to see, is it going to work if we do 3 times 5 minus 3 times 2. Is this going to work out? Well, on this side, 5 minus 2 is 3, so we'd have 3 times 3. 3 times 5 on the right side is 15, and 3 times 2 is 6. So 3 times 3 is 9, and 15 times 6 is also 9. So yes, it works out. It doesn't matter if it's addition inside the parentheses or subtraction inside the parentheses, the distributive property is going to work for you. Lastly, here to close out, it's asking you to think about the expression 3 times the sum of 5 plus 9 and the expression 3 times the product of 5 times 9. Could you use the distributive property to simplify both expressions? Why or why not? Well, we're just going to do these and see what happens. So if we use the distributive property on 3 times the sum of 5 plus 9, you can see that it works out. We get the same answer on both sides. However, on the right side, if we try to take 3 times the product of 5 times 9, we get one answer. On the left side, we get 135, and on the right side, we get 405. Well, they're not equal, so it doesn't work. To try, when it's all multiplication, to use the distributive property does not work. So we're done with the lesson here. Again, please feel free to rewind and look back at something if you don't quite understand. Or again, you can always ask me, and I can come help you with anything you're maybe not getting. Otherwise, don't forget to do the assignment online on the Pearson site, and then turn in your note sheet when you're done with your homework online so that I know that you have completed it and I can check it.